My name is Behrad. I work in the Department of Ophthalmology and Visual Science at the University of Utah. And my research is mostly about understanding how the visual cortex works and how our cognitive functions, such as attention and working memory, incorporate and employ visual cortex to achieve, our daily behavioral goals. But what I'm trying to do today is mostly just giving you a general idea of how to read a scientific paper. And feel free to stop me anywhere at the middle. But what I'm going to go through is basically give you a very general overview of components of a scientific article, how to prioritize various parts of a scientific article when you're reading it, and understand the rationale for such prioritization, and also giving you a few hints about where to find the punchlines, how to read different parts of an article, including a figure, and where to find the punchlines of the paper. So let's just start with, because we just are behind already, I'm not going to take so much of time at the beginning. Let's just jump right into the material. So scientific articles are different than, say, reading a article in, say, New York Times or on the CNN website, for example. They have a certain type of a structure. They are usually using such platforms, such arrangement of different sections, which is having a title, list of authors, a short summary of the findings and the point of the paper, abstract, introduction about what the idea is and what the research article is trying to achieve, methods and materials that are used to achieve those goals, results of their finding, figures, and then a discussion based on their results and findings regarding their goal. And then at the end, usually you end up with a set of acknowledgement and references at the end of the paper. So I'm just excluding what is kind of like less important for reading a paper. And I'm going to just focus on these 6 parts: abstract, introduction, methods and materials, results, figure, and discussion. And this is these 6 sections as they are sorted, as they are appear in the final published form of a paper. Usually you see an abstract, then introduction, methods, material, results, figures, and discussion. But what is important is that if I want to sort it by the information content, probably this is the order that you should expect, that most of information per number of words is condensed in the abstract part of the paper. Then a lot of information is in the figures. Then results are a more expanded form of describing the figures and findings in the figures. And then usually you have introduction and discussion, depending on how much of information you're putting into, like, okay, how much is the background, or how much is this finding giving us information about the future steps. You have introduction and discussion there. And then usually methods and material is just a detailed extended form of information that is needed for understanding how this research is done. Actually, let me check my chat as well, make sure. All right, that is not for me. All right, so this is the list as sorted by information content. So by this time, you should probably have an idea of, if you want to read a paper in your field, this is probably the way to read it. But one thing that is important is, okay, so you saw the difference between appearance and content, but what is important is the order to read might be different if the paper is not in your field, meaning that if you don't know what the background is or how this research is usually done, you probably need to spend more time on introduction and methods and materials to understand where this article fits in, and then start reading, okay, what the results are, how they are showing their claimed reports, and how they discuss these findings. So if I want to give you an idea of how this changes the way that you approach a paper, you should understand that it's a spectrum. If you are less familiar with the paper and with the field, then you have to spend more time on introduction, methods, material, abstract, and discussion. But if it is in your field and you already know, okay, this group is working on, I don't know, like object recognition in visual cortex, you can just jump right into their figures and results and see, okay, what is the new finding that this group has? And you probably don't need to go through, okay, you know that what they are doing for their methods, you know what the background is, so you can just directly jump to these figures and results and get an idea of judging the results and discussing them by yourself. So to give you an idea, obviously, if you are reading a paper that's not in your field, you have to spend more time to get up to speed and then start understanding the result. Otherwise, if it's in your field, you can just jump right into the main dish. So there is no way to, yeah, I think that's kind of clear up there. So what I used for this talk as a sample of a paper is one of our papers that was published basically the first year that I gave this talk. So I kept the same paper. But what I'm trying to do here is that rather than telling you how to read a paper, I'm going to tell you how a paper is written. And hopefully this gives you a better idea of why different parts of the paper have different, you know, value and different amount of attention is needed for each of those aspects. So this is a paper that was published in 2018. Here's the authors, correspondence. There is a short, smaller than abstract actually format that for this journal, we needed to present a very short, brief summary of what's happening there and a bunch of highlights. But what I'm gonna tell you is how we wrote the paper. So before going there, let me just start. Maybe you guys can unmute yourself and give me an answer. So one question that I have is that between these parts, what do you think authors usually start writing? Which part an author starts writing first? Between, say, abstract, discussion, methods, material, introduction, results, and figures. What is usually the order that a paper starts forming up? Anyone want to take a hit?
We have some guesses in the chat. So results and discussion, maybe figures, maybe abstract, maybe methods, abstract methods, introduction. Oh, yeah. There's a lot in there. Yeah.
Yeah. So actually, yeah, I think so. Methods and materials are not. Let's just clarify why, because you can think of it this way, that writing a paper is like writing a story. You do need the punchlines there. You know, here is the story of, I don't know, whatever story, and there is like this character and that character doing this. So when you write, you don't go through, okay, you know, what the setup and arrangement is. You just have a sequence of events in your mind that you want to walk through people into the story. And usually, I mean, you can think of, like, in your mind, you usually have the abstract form, meaning that you know what the general storyline will be. But most of the time, the difficult part is to have the punchlines ready, and punchlines are usually the figures, meaning that you want to have figure one telling story one. Then from here, you take the reader to the second part of the story, which is figure two, figure three. And what is important in reading a scientific article is people will evaluate the strength and the robustness of your results and the solidness of your findings by looking at the figures and figuring out, okay, how much of information can I see there? How strong their claim is? Can I see the effect that they're reporting in that figure? So that is kind of like the idea behind the fact that you want to start with figures. Make sure that your punchlines are set before you walk into the paper. So the answer to which part you usually start working on is indeed the figures. And I'll show you how, for example, for this paper, we start with such sequence of, expand it more, starting with figures and captions, results, methods, introduction, and then all pieces together. So let me just show you how the writer starts a paper. So draft 8 is, for example, we had these 4 figures and we call it first draft, that now we have the punchlines there, that we have, okay, this is figure 1, this is figure 2, and we know that, okay, in figure 1, we are going to tell them, you know, this is what the paradigm that we are using in visual cortex to record activity. This is the first finding that we are showing, okay, red is more than blue. So we know what the punchlines are. And then we start with, at least, you know, my method. There are several methods, obviously, but I'm just telling you that this is just a general trend that you want to have your punchlines sorted out up front. So in figure 1, it's a task. We didn't write that much about it. We know it's easy to write. But in figure 2, we show this point, then this point, then this point. You know, you just go through the punchlines, make sure that you have an extended form of writing what is happening there. And then in figure 3, we are showing this, and every step you just walk the reader through it. So now we know that we have a paper. We have something that is that has a storyline, and then we just basically left everything else aside. And then later on in draft 9, we go to extended form of results, meaning that now we have, okay, we start like putting different parts of the paper, abstract, there should be, we know that, okay, it's 120 words, we're going to take care of it later. We know what is in our mind already. But now we start like writing the results in a more detailed way, meaning that now that extended figure that we had becomes, you know, a detailed description of the results with all the details of, you know, p-values and mean and standard deviation. Everything there is explained, and then figures are probably inserted there with a little bit of caption for them to describe what the figure means. So now we are, I would say at this stage, you are probably like 80% done with the paper. The rest is just writing the stuff. And now you can start writing things that are easier, methods, introduction, and usually there is supplementary information, meaning that, you know, there is a specific effect that you're reporting, but it's not part of the main story, so you leave it as a supplementary figure. Some journals allow having supplementary information, some don't. And then you just gradually add these parts that are, if it's a paper that you've been working in that field for a while, you already have some text for describing the methods that you're using, and you already know what is happening there. Say for example, you're writing a paper for your thesis, you already have written your proposal up front during your PhD that tells people, okay, this is the introduction to the question, and this is why this question is important, and this is how we're going to address it, and this is the approach and method. So you just basically take those parts from your proposal, and because this is already done and you already started this line of research knowing what you're going to do and knowing why you're doing it. And then adding all these pieces together, then for most of the journals, they ask for cover letter, highlights of the paper, a summary. They sometimes even ask for like suggested cover photo for their journal, things like that. Each journal could be different, but you just add these as you go along. And then the process is like that you submit this paper that is probably like draft 27, for example. Let's go take a look at it. Then we had, this is probably the latest draft that's pretty much ready to be submitted. You can see how it looks like. And so we have everything there. Still keep tracking few items to fix. And basically all components of the paper are there already. References, acknowledgement, figures, captions, references at the end. And then there is another supplementary file as well. And then what happens is that you submit the paper and you usually get a revision, meaning that there is a set of reviewers that they review your article. They have some questions, you answer those questions and submit it again. Then in this case, we actually received another round of questions. We revised it again and submitted again. Then the journal said, okay, it's accepted. Give us a few small items here and there, like, okay, what type of animals were you using? Details about the methods that are not crucial for killing the paper, but they are like part of the requirements for the journal to check everything. And then they send a proof to read and make sure that there is no glitch here and there. And then we just basically come up with a set of, here is issues that they found, delete A, add this, things like that. They make a list for you. You proofread it, finalize it, and then it will be published at the end in a paper like this format, right? So this is the sequence that most of scientific articles take, with a little bit of like wiggle here and there, but you can get an idea of why now I was emphasizing on, having figures, captions, and results up front. That takes you 80% of the way. By that time, you know that, okay, first of all, how strong my results are, what level of journal can I submit these results to, and which points, if you have other colleagues to comment on your work, you already know that, okay, these are the main critics that I'll get by showing these type of figures to people. So as I mentioned, there are two different, there is the main punchline of the paper is the figures. So I spend a little bit more time on how to read figures. So I put two of the figures here. One is, that's figure 3, that you can see. This is how a figure is usually formatted, right? There is different panels there, A, B, C, and here is a figure 3 with a little bit of title about what is the point of the figure is, and then each section describes what is in the figure. And what you should know is that the proper way of writing is to have the captions describe the figure, not describe the results. Meaning that, in C, the SPL is shown for memory in versus memory out, and that's it. The interpretation of results usually happens in the results section. So I actually put this figure 6 as a sample here for this presentation indeed. So because what I realized last time from people asking questions after was that they were asking about how to read the results and link it to a figure. So let's just keep everything in one slide here. And so here is a figure, that figure 6 that I mean, probably you don't need to understand everything about what the point of the figure is, but what I want to walk you through is that, okay, here is 2 panels for the figure, and I took part A and B from the figure caption. Part A describes that discriminability for location of a visual probe based on a spike count, which is firing rate, during memory in compared to fixation. So that is describing the figure. The scatter plot shows the average ability of individual neurons, which is these points, to discriminate probes. And then it describes also the diagonal histogram shows the difference between memory versus fixation. So as you see, the caption only describes what the axis labels are and what each data point is and how the, say, this diagonal histogram should be read. But in the text, what we describe is this. As we've been anticipated, we found that D prime index, which is this discriminability index, is measured using the firing rate. The discriminability of probe location does increase during memory in compared with fixation. And this is how you read the result. And this is apparently the part that people were asking last time to practice it together. N equals 109, meaning that we recorded 109 neurons, and now in the caption, it says these are individual neurons of MT visual cortex that are recorded. And D prime for fixation is 0.34. So the average of these points on the x-axis is 0.34. And plus minus a standard deviation of 0.018, meaning that one deviation from one standard deviation from this mean is 0.018. So it's just describing the data. It's actually the standard error. And I don't want to go through the statistics part of it for now, but this is how you describe a data, right? That you say, okay, here's the mean and the standard error of the data for fixation, and then for memory, it was 0.417 plus minus standard error, and the difference between this value and this value was significant because the p-value using the Wilcoxon signed rank test is less than 10 power minus 3. It's a biostatistic class that you need to take to understand why did we use this test, what does that p-value mean. But this is how you read a text that is related to a figure. So get an idea about how to understand the figure using the caption, and then look at the statistics based on what is mentioned in the result. And usually at the end of results section, you'll have, okay, therefore this result shows that discriminability during the memory condition is greater than the fixation condition. And this is usually true for most of like scientific papers, that you get an idea about how to read the figure, you get an idea about what the figure is showing using the results section, and then get an idea about what these results mean by reading the discussion. Or if it's in your field and you're an expert in that field, you can also interpret it yourself. So any questions so far up to here? Let's take a pause because this is, where is the, oh yeah, still. All good there. So yeah, let's go to the next part, which is, now that you have an idea about how to read the main part of an article, here is some clues about how to get some help from other parts. So you should know that, first of all, I should say that reading a bad paper is going to be difficult. If the paper is not written very well, meaning that the author does not know how to start with the big picture and then describe the details, then you're going to struggle. But if it's a paper that is written, the author has gone through a writing class already, they know that they should put their punchlines at what part. And usually this is what's happening, that first sentence of a figure caption is important, like you saw in this example, right? That this sentence already tells you what this figure is going to show. Oops. And then for each paragraph, let's just go to that paper, for example, and the first and last sentence of a paragraph should usually give you a summary and introduction of that paragraph. This is what everyone tells you in a writing class, that you start your paragraph with, here is the point of the paragraph, then you go through the details, and at the end you just conclude it with something. So if it's a paper that is written with this style that is recommended, you should be able to get an idea of what each paragraph is going to do for you by reading the first and last sentence of the paragraph. And then what is also very important in research articles is that in your abstract, you usually, if it's a serious journal, you need to have a last punchline. And this is also a very good place to look at, okay, so now I got the whole picture of what the results and figures are, what the abstract tells me, but what is the point of this paper in terms of bringing the field a little bit more forward to a certain goal? You usually get it at the last sentence of the abstract as well. And also the first paragraph of discussion, most people try to, because what happens is that you start with the abstract, start with introduction and telling everyone what the story is, then you go through a lot of details for results, and then what you want to do at the end of your paper, if you're a writer, is once everyone is out of the forest, you want to tell them, okay, forget all the trees, and here is, just look at the jungle, look at the forest. And you just summarize everything at the first paragraph of the discussion, that figure 1 we showed it this, figure 2 we showed it that, figure 3 this, figure 4, 5, right? Just walk everyone through it, so make sure that they're not lost into all those details of the results section, and you can bring them back to speed, now telling them, okay, what is the story and why this results is going to show you the things that we're going to discuss. So that's also another important part to look at. And also last paragraph of the introduction usually serves the same purpose, meaning that when you tell everyone that what the idea is in the introduction, at the last part of introduction, you usually tell them, which is this, tell them what they are going to expect in the future results section. That you're going to tell them, okay, this is what you're going to see, and the significance of these results are this. Now let's go read the results. So usually you can get an idea of what, I mean, if you want to have be a quick reader, just going to the punchlines, you can get an idea of what they're gonna tell you at the end of your introduction, because they're gonna list what you're gonna go through, and then look at the beginning of discussion where they are gathering all the information and reviewing everything that was said during the discussion, during the result. Then if you want to see their points, you can take a quick look at the figure captions, and usually actually the first sentence of the figure caption tell you what the point of each figure is, and also go to further details of each result section by at least looking at the first and last sentence of each paragraph. This gives you something that within 15 minutes you can get an idea of what this paper is going to tell you. And if you want to see how these authors see their paper in the overall context, you can see how they are discussing it in the last part of the abstract and their discussion. So this was the just giving you an overall view of how to read the paper and where to find the punchlines, how a paper is written. So it gives you an idea of putting yourself into the author's shoes and see things through their eye. I just have few small points to add, which is, I think by now you should have had enough information about how to read the paper. But I just want to give you a quick review of, there is first of all, as I said, the paper should be written efficiently. You're out of luck if it's a paper that is not written to a certain style. You should read the whole thing to make sure that you understand you're gonna be struggling. But if it's a high-profile journal, they are usually taking care of it already, and they have already found ways to carry the message directly. But as a general reading skill point, there is a 3-round method that I actually asked Stephanie and Megan to share this paper with you, how to read a paper, and it tells you the 3-pass approach of first pass, having a general overview, second pass, more details, and third pass, the critical part, the critical thinking part. So it's basically round 1, you want to find the punchlines, what's the point of significance, main arguments, main questions. And what I told you about the punchlines is usually used for this round 1, to give you the general overview. Then for the validity of answers, you need to get into more details. You need to read their figures, read their description of their figures in the results section, how these findings contribute to our knowledge. All these things takes another round of reading, more than that first round of 15-minute part. And then for being able to criticize a paper, you should be in that field, meaning that you should know what this paper is talking about in the general domain of, trend of the field, what these methods are used usually for, and what are the major criticisms about these type of methods and materials. So that is the part that usually you go into the details of methods, details of findings, and the strengths of their findings and their real significance. And this is, as you can see, this is faster, and this becomes more and more time consuming to go into the all details. Basically, like when you're approached by a journal to review a paper, you can do this in like 15 minutes, but then in order to be able to criticize the paper, you have to read it to a much more detailed depth and be able to criticize different parts of the paper. So I already shared that PDF with you, and I hope that Megan and Stephanie will share it with you. Just one other interesting paper that you can use is, there is this science journal article about how seriously read scientific papers. And I just only took a few points off of that, but you're welcome to go read the whole paper. I'll just leave my screen on for a couple of minutes to read these points together. And this part as well.
Really quick, can you just tell me, can you hear me?
Yes.
Okay, can you tell me what that second point was? The first one was focus on what you need to know. What
Yeah,
was
so the second point is actually what I mentioned, that, if it's, when you're a PhD in your field, you become an expert, meaning that you'll be able to judge the significance, strength, and value of a certain result by yourself. You don't need to go read someone else's, which is the author in that case, interpretation about the result. You know what I'm saying? You just see this figure and okay, wow, that's a strong effect. That means most of the time neurons showed higher firing rate during memory than fixation, and that's a pretty sizable effect. So I don't need to go read the author's interpretation, and you don't want to be spoon-fed by the author, basically. And what it says is that if it's in my field, I don't really care much about, because they often reflect the author's predictions and the way that they interpret things about the results and methods. So I have my own judgment. But if it is something that is not in your field, you're kind of like at the mercy of the author, to be fair, and because you don't know the whole picture so well to judge it by yourself. You are usually spoon-fed by the author if you are not in that field. So you kind of rely on their interpretation and their way of, posing their result to the field. That's the point, kind of.
Okay, thank you.
So there is one chat. Oh yeah. So yeah, let me stop sharing my screen so I can see. We got like, I think 9 minutes, which is good for having questions and answers. Any question, any specific part that was not clear? Again, the idea was to give you, the author's perspective of how a paper is written. And this will give you a better way of understanding, okay, what parts were the main intention of the author to write with clarity, and what are the punchlines, where to find them. But again, having said all of that, you're still at the mercy of a good writer versus a bad writer. That if they don't use a certain type of writing style, you're kind of out of luck. Sure, yeah, thank you, Arubi. But what I understand is also this part was where most of the students struggle, which is, oh yeah, actually, let me share it one more time. I think what I realized was when people say that, okay, could you tell us how to read a paper? Most of the time, they are not concerned about, could you tell us how to quickly read a paper? They are asking me, could you tell me how to read a certain part of a paper? And most of the time, people usually, actually, students that are just getting started in a scientific field, they struggle with reading a figure and reading the results section. And I understand these are really difficult to understand, all these cryptic messages there. But after reading like the first 10 papers, you're gonna learn that, okay, this is y-axis, this is x-axis, this is the line of unity. If things are above the line of unity, that means y is greater than x. And in order to read it, you read the text. It tells you how many sample sizes you had. It tells you what measure was used for these two axis labels, say d prime, which is discriminability, and the value of x is this, value of y is that. As you can see, y is greater than x, as you can see in this points being above the line of unity. These are going to take time to familiarize yourself with how to read scientific figures. And in order to do it properly, you do need to know statistics and biostatistics in this case specifically to understand, okay, what does this mean relative to that? What is it? 0.016 variation good when the main signal is 0.4, and these will take some practice in statistics and understanding, the descriptive statistics basically. What does that p-value mean? It tells you what probability of seeing such phenomenon is, and what is this test doing, Wilcoxon sign rank test, and how to apply certain biostatistical tests on your data as appropriate. That takes another full course to just know. But usually what people say, we don't know how to read a paper, stills down to we don't know biostatistics of reading results yet. So if you're struggling with reading details of a paper, usually it means that you need to know more of statistics, and you need to know more how to read scientific communication, basically, in terms of statistics. So there was one more chat, I believe. Let me see. If you're doing research, Papa asked, if you're doing research in a familiar field, is it a good idea to use similar statistics methods for your research work? What do you mean similar statistics method? So as I said, like for each point to make, for example, you want to say memory count of spikes is greater than fixation count, for example, for that figure. You do need a Wilcoxon sign rank test in that case. But if you want to say memory information is correlated with fixation information, that requires a correlation statistic method, meaning that, okay, you have to report it, say, Spearman correlation or Pearson correlation. But usually there is a set of statistics methods that are pretty common actually across, say, take it from math to physics to biology to chemistry. These set of statistical methods are kind of universal, meaning that whenever you want to talk about correlation, you use Pearson correlation. If your data does have outliers, you use Spearman correlation. If you want to compare two, say, blood sugar of male and female, you use t-test. If you want to compare something that is more and has like outlier data or is not a normal distribution, you use Wilcoxon sign rank in that case. So set of statistical tests are kind of universal, but the answer to your question is that probably it is true that you're going to end up using only a limited set of statistical tools throughout your career. Like if you're a computational person, you may use like different set of GLM, generalized linear model type of work. But if you're just a say endocrinologist, you're mostly using like measuring blood sugar and doing like a t-test or sign rank on that. So yes, you're going to end up with a limited set of statistics, but you should know the larger scope. I appreciate the author's perspective. That was new and helpful to me. Thank you. Yeah, I'm sure like if you know how a paper is written, it's going to give you a better perspective of how to put yourself in that person's shoe. Okay, so pretty much on time with all the delay and stuff.
Yeah, no, you did an excellent job. Thank you so much. A few takeaways for me. I really liked the idea of the punchlines and kind of figuring out where you can quickly identify those in a paper, especially if you're looking at something that is not in your field or while you're developing expertise in your field, like kind of easy ways to get the main points across or the most important points across. And then also thinking about reading an article many times in through different lenses. So yeah, reading it just to kind of get the general idea, but I also like to focus on, you know, doing a critical read as well. Like, even if you aren't an expert in that area, you know, asking questions of yourself as you're reading it. And then, you know, once you're more familiar with the specific methods or the statistical analysis that happens in that area, you know, like the point that was brought up from the other article, that, you know, they read the methods a little bit more closely because they know what, so they can kind of come to their own conclusions. It's not necessarily as important for them to read the results. So I liked that there's kind of a spectrum from, like, you might, depending on your level of expertise, but also if you're reading something in your field or not. So I really appreciated all of those. So thank you so much.
Just the last point is that all what I mentioned is how to write experimental research articles. It is, if you are, say, in a music department or political science department, or even sometimes psychology department articles, they have a different approach. They have a different way of arguing and counter arguing. So it is not usually like experiment-based approach. So the way to read those papers is beyond what my presentation was today.
That's a good point. All right. Well, thank you so much, Dr. Noudoost. I really appreciate your presentation. Thank you. And oh, I need to share my slide. Yeah, so thank you for presenting. Thank you to all the students for attending. I hope that this was useful to you. It sounds from your comments in the chats and things that it was useful. And don't forget to fill out an evaluation, especially if you're watching this as a recorded event, so we can keep track of your attendance. And that's it. Thank you, everyone. Have a good day.
Excuse me, I had a question real quick.
Oh, sorry. Yes.
All the information shared as far as like the links and such, those will be available after the fact. I'm assuming wherever the recording will be stored.
Yes, that's an excellent question. I should have mentioned that. I will be posting the recording either later today or tomorrow on the URES website. And then that will also include the presentation handout for the how to read a paper article. Yeah.
Thank you very much. And thank you to the presenter. Appreciate it.
Thank you.
Have a good day, guys. Bye.
Thank you.